This is lesson 1.3, writing expressions. You should be on page 15. To translate a verbal phrase into an expression, now remember, expression means we could have numbers, variables, and operations. You want to look for words that indicate mathematical operations. Now again, there's some vocabulary that we probably should review. Operations mean adding, subtracting, multiplying, or dividing. I'm just using the symbols there, okay? So we're looking for words that indicate operations. So they have a list of those here, which we should get in our notes. Now, the following words that I highlighted mean addition: sum, plus, total, more than, increase by. All those words indicate addition. The word that I would be most worried about is the word sum. A lot of times I see the word sum used in a sentence like right here, and people don't know that sum stands for addition. The sum of something is the answer you get when you add. Okay? So those words mean addition. Let's move on to subtraction. The following words indicate subtraction: difference, less than, minus, decreased by. Out of all the words in the list, the word difference would be the one that makes me the most nervous, because I see a lot of papers over the years where people read the word difference and they're not sure what it means, and they don't know that it means subtraction. Difference is a subtraction. Here would be an example: the difference of a number n and 6. That word difference is telling you we're subtracting n and 6. Multiplication. The following words mean multiplication: times, product, multiplied by. The word of means multiplication when we have percentages. Here's a couple more that I added: double, triple. Double means you're multiplying by 2, you're doubling. Tripling means you're multiplying by 3. Out of all the words on the list, the word product is the one that makes me the most nervous. Again, I see a lot of times where we have the word product in a statement and people don't know what it's asking. Product is multiplication. Finally, division. The words quotient, divided by, divided into all indicate division. Quotient is the word that makes me most nervous here. People come across problems with the word quotient in it, and they don't know that quotient is telling them to divide. Okay? The order that you use is important when you are subtracting or dividing. Okay, now, so maybe I should put a little star. Addition and multiplication are a little bit easier because it doesn't matter what order you put those in. For example, when you look here, the sum of 2 and a number x, if you write 2 plus x, that's correct. But if you put x plus 2, that would also be correct. When you add, there's a property called the commutative property. You can rearrange the order of adding and it doesn't change anything. It's the same thing with multiplying. Think about it. 3 times 5 is the same as 5 times 3. The order doesn't matter. But when you subtract, and maybe I should put a little exclamation point here next to the subtraction and next to the division, for these two, that order is super important. You got to write things in the proper order. Here would be an example. The difference of a number n and 6. You have to write that as n minus 6. You can't write it as 6 minus n. That's not the same thing. Or the quotient of a number k and 2. That means divide k and 2. You got to write k divided by 2. You can't put 2 divided by k. The order matters when you're subtracting or dividing. Let's practice a few. They have a few examples of verbal phrases where we have to translate into an expression. Remember, the word expression, let's review that. Expression means that we have numbers, variables, and operations possible. So let's read this. 4 less than the quantity 6 times the number n. Well, I put a few notes here. The word less than is telling me subtract. Times means multiply, so 4 less than. I'm taking away 4 from something. Think about that. If I say 4 less than your age, you'd subtract 4 from your age. So 4 less than means take away 4 from something, and I want to take it away from 6 times the number n. Well, 6 times n, I would write 6n. Well, there's the expression, 6n minus 4. What about the next one? 3 times the sum of 7 and a number y. Okay, times, that's pretty easy, that's multiply. Sum, that's adding. I want to take 3 and multiply it with this addition. So I'm doing that over here. Here's 3 multiplied by the addition of 7 plus y. Sum is addition. The difference, remember, difference is subtraction. The difference of 22 in the square, that means second power of a number n. So subtracting second power. So the difference, we're subtracting, we're taking 22, we're subtracting the square of m, which is how we get to here. Okay? Those are some examples of translating verbal phrases into expressions. Here's another practice. Let's translate the phrase the quotient, that means division, when the quantity 10 plus, that's adding, 10 plus the number x is divided by 2. There's division again. Okay? So let's write that out. Okay? I'm taking 10 plus x and I'm dividing it by 2. Okay? The quotient, the division of 10 plus x divided by 2. Okay? 10 plus x divided by 2. You will get practice on writing verbal phrases into expressions in today's assignment. It's one of the I-cans on the list. One of the things they're going to have you do is write expressions for real-life examples. Now, these are abstract, so let me read this, and I have a teaching point I wrote up here. A piece of ribbon L feet long is cut from a ribbon 8 feet long. Write the expression. Now, when I was your age, when you threw a variable in like this, that just threw me for a loop. Like, I just had a hard time picturing that. So here's a good teaching point. Replace the unknown with an easy number. Like in the book, they replace L with 2. So let's reread this again with the number 2 in for L. A piece of ribbon 2 feet long is cut from a ribbon 8 feet long. Well, here's a picture. Here's an 8-foot long ribbon, and I'm cutting off this 2-foot piece. How much is left? Well, when you look at it that way, you're probably like, that's easy. You take 8, you subtract 2, I must have a 6-foot long piece of ribbon left. Okay, well, you know what to do then. You're going to take 8 and subtract whatever you cut. Well, I want to cut a piece L feet long away from the ribbon. So I'm going to take 8, I'm going to subtract away what I want to cut, and whatever that's the answer. That's an L, by the way, a cursive L. 8 minus L would be the remaining feet on the ribbon. That's an abstract problem. That's how you can get through that. Just replace it with an easy number, and then you can think through it. A verbal model. What is a verbal model? A verbal model describes a real-world situation using words and labels and using math symbols to relate the words. I guess I'm going to say that in my own way. Verbal model means you're going to write an algebraic expression for a real-life situation. Now remember, the term algebraic expression means numbers, variables, operations. You're going to write an expression with numbers, variables, operations for the real-life situation. That's what this is saying. That's what a verbal model is. Okay? They show an example of this here, a verbal model at work. You work with 5 other people at an ice cream stand. So let's think about it. It's you and 5 others. There's 6 people working then. All the workers put the tips in the jar and share the amount at the end. Let's just make up a number. Let's say you had 24 bucks in tips. Let's think about that. If there's 24 bucks in tips and 6 people have to share, what would you do to figure out how much you'd have? I hope you're thinking I'd take 24 divided by 6 and I'd get 4 bucks. That's my tip share. Okay? Do the same thing. Here's the only thing. They did not tell you how much money you got in tips. We don't know that it's $24. So we're just going to say we have $A in tips. Well, I would take A, divide by 6, and that's how much I would get in tips, whatever that is. I can't actually give the numerical answer. I don't know how much in tips we got. But the expression, the procedure to getting the answer would be to take whatever A is, divide by 6, and that would give me the response. That's why in the book, you can see here, maybe I should erase this out, they're saying the correct response for that is A over 6. A couple last things. Unit rates. A rate is a fraction that compares two quantities measured in different units. So a rate's a fraction. It's comparing two different things that are measured in different units. Maybe I should give a quick example of that. Here's a rate right here. 110 miles over 2 hours. You can see we have different units and we have quantities, 110 and 2. That's a rate. A unit rate is when you take your rate and you rewrite it so that the denominator, now think about it, the denominator, do we all know what that is? The denominator is the bottom of our fraction. If the bottom of the fraction is 1, that means you have a unit rate. So we can change our rate up here. We can find the unit rate pretty easy. Here's my rate, 110 over 2. If you take your calculator and you take 110 divided by 2, 110 divided by 2 is 55. Here's my unit rate. 110 miles in 2 hours would be the same thing as 55 miles in 1 hour. My unit rate is 55 miles per hour. That's the end of this video. I've covered everything I need to cover. We can get to work, and if you have questions, just ask.